Welcome to scaling transactions using OMQ and JSON. If I say ZMQ, it's the same thing. We just get into one nomenclature at the office versus the other. This is what we kind of learned from going from 03 on up as I worked for this company. So there seems to be a large amount of cat images that I see when we come to these, so I decided to pick something different. I like to call this image entering with confidence, and it'll be a learning thing later. I work for a company called EPX, that's Electronic Payment Exchange. We were bought out and we're owned by a company called North American BankCard. Generally speaking, we're a credit card processor. We process about $50 billion a year in transactions. I've started with the company just a little bit into 2017. So a few housekeeping things. There's been a lot of really pure C++ talks. This isn't really one of those. I will go over some C++ code. But seeing the last talk that was in here, we're kind of a lessons learned talk. I work for a financial transaction company, so if you're not familiar with it, I will go over a little bit of a map of financial transactions and where we fit in that picture. As a development group, when I joined, we like smaller header-only files. The company likes to be able to get stuff that they can pull into their repository, and should it ever disappear from the world, they know they can ask us to take care of it, add to it, and change it. OMQ is primarily a C library. So if you go download it, you'll see that it builds and everything is a C library. We use the C++ wrapper, which they talk about, which is CppCon. The guys on my team, we certainly are not ZMQ experts yet, but we keep learning with it. Our backend libraries and the code that we'll have for you to download if you want to play with it is all C++. When I suggested this talk, I got a review saying, how could you talk about Visa and MasterCard stuff? You're going to be in trouble. And just to say, you can go to EMVCO if you're interested in that chip on your card, and it's all open standard. You can actually get down to the details of finding what the voltage has to be to activate the chip on your card. And if you need to sleep at night, it's also good reading. And so there should be no PCI compliance issues here. If there are, I'm sure I'll hear about it when I get back to the office. So we're EPX, and if we look at this graph here, we kind of fit in the middle of everything. And so around the circle, we'll start on the top. You have merchants, and this is your stores you go to where you're using your card. And we take everything from the web terminals, that can be your iPhone where they stick in a square device to take something, physical terminals, all the way down to the brick and mortar where they still use a dial-up modem, AT/DT, in order to send us the transactions actually, to APIs. We have companies, for example, that will manage gym memberships. They sell their software to a gym, but then all of those transactions then get processed through us. So when that data comes in, we call it an authorization. And so when you go to swipe your card, the first thing we do, that transaction comes to us. We do some massaging. We make sure it doesn't have any fraud issues and such like that we can see, and then we forward it on to the issuing bank to say, hey, is there enough money? Can we do this? All this has to come back in 30 seconds or less, which is really exciting when you need to make sure something hits and you have a hard deadline. It has been fun to code for that comparative to what I used to do. The flip side is we have the other half of that, which is called settlement. And the best way I can explain this is if you go into the restaurant, you swipe your card and you pay for your dinner, they bring you the receipt, and you have your tip amount. And so, if you put something on the tip, what generally ends up happening at the end of the day, they'll close out and they settle in batches. And so what ends up happening is they apply that tip amount, it all gets put together in a batch and gets sent to us. What we end up doing then is taking the two, putting it together, updating our records, and then based upon where the card came from, we have to split it out into the various card vendors, American Express, MasterCard, et cetera, as you can see there. The brand cards that you see is kind of interesting because, depending on where you come from, if you have a Kohl's or a JCPenney's or like even Amazon, they have their card versus their Visa card. These are brand cards. And so we get all kinds of things that are even outside the scope of your Visa, MasterCard, gas cards, etc. Anybody here know what EBCDIC is? Yeah, we still use that and have to deal with that. There's, some really old stuff that's around because, like I said, we still have machines that they're dialing up with a modem to be able to end up reaching us. At the same time, last year I got a spec from one of these major card vendors that was in beta that we then got to code for the next 6 months as it continually changed in beta. So I like to joke, and this is just my personal view, that there's more card specification documentation than there probably is code written to run the cards. So my job at the company, and for that of my team, is we have legacy software that we're moving forward, and that's what the talk is mainly about, what we've learned from it. Our legacy software is written in an application called Power Builder. If you're not familiar with it, it's kind of a very old version of what Access was. Borland had it originally. SAP owns it now. We do have some stuff that was written in C++ Builder. Oh, I love looking at C++ Builder compared to Power Builder. So does everyone on our team. It is a Windows-based application, though. So they take the Power Builder application, it compiles out to basically a Windows app. So we have clusters of Windows machines set in an A/B configuration so that we have failover, and that's the type of application that runs it. It's not really a daemon. On one hand, we do have these apps they're tied to an Oracle database backend, so we do have a lot of database infrastructure, but these are the apps that we're working on replacing. Normalization. You ever had a table with 300 fields in it? And then when you're trying to convert things, they're like, hey, 25 of these you just might not need anymore, but we can't really remove them because they were needed before. We love normalization when we can apply it. So one of the other thoughts that is given to me when I suggested the talk is, someone's like, you should never rewrite code. We saw that with Netscape, and they're right, but the fact is we have a product that will not be around much longer. We don't know if SAP is even going to support it. So we have to end up doing a rewrite to keep business going. So from our perspective, or at least my view, our technical debt comes from some outdated tools that we have and those legacy implementations. Of course, as you try to implement these things, you do everything you can to prevent as many new bugs as possible, because whenever you're looking at old code, it's like every line that was added was probably a bug fix, and you got to keep that in mind. Power Builder as a code base to convert to C++ is definitely not a one-for-one. The one good part that we have is when you're in these kind of processing environments, at least for us, we have lots of small apps. So, when we're looking at that map, the web authorization is actually one small app on its own. Authorizations as they're passed through is another small app. So we really get a decent ability to do a replay. We can take, 100,000 transactions that come in from one side, push it through the app, and make sure that the output is exactly the same as the input when we put out a new application. However, that doesn't mean that we aren't testing as much as possible to find our newly implemented bugs. And I joke about it that way because sometimes you can have one data field where somebody typed a U instead of an I because they were moving the field over. And fortunately, it did or didn't affect something, but that is one of the things that we deal with. So to the technology. All right, so we're using ZeroMQ and JSON. They used to use sockets and XML. We like ZeroMQ because it's been incredibly stable, as we've seen from other companies using it. It's brokerless, though we don't always use it that way ourselves. I put C0MQ just to make the point that it is a C library, and if you really want, you can get to the nitty-gritty with it that way. But we do like the CppCMQ that's wrapped over it. Why JSON instead of XML? I'm not sure if that's really a question. Readability, portability and size. I get XML is portable and such, and it can be readable. And the size part we'll give an example of in a minute. But some of the other synergies that we get is ZeroMQ uses character pointers or character arrays by default, and that's exactly what we get with JSON. And we also use Oracle. Oracle has an interface called OCCI, which can do data buffers. And data buffers, instead of doing a single insert, if you will, or even a parameterized insert, we can actually set up an array of, say, 10,000 inserts. And once you give the column definitions, you can pass it all up. It's basically all strings, but because Oracle has the column definitions, it'll turn around and do the data conversions for us. And it gives us a lot more, incredibly more speed versus single inserts.
Are you describing what ended up in the result, or also what used to have been before?
This is what's coming through and where we're going in the result. And I want to be able to show you guys a demo. So I love questions, and I'll talk to everybody afterwards. But I'd like to be able to show. So if we can hold just for a moment. So our first problem we ran into, like I said, it was called entering with confidence. So when we moved from 03 trying to get to a C++11 compiler, we used CentOS 6, which did not have one by default. So when you look at the sample code, if you download it off GitHub, you will see it defined in the makefile for this glibcxx ABI equals 0. I don't know if anyone's really familiar with the ABI, but when we upgraded for Oracle, on one hand, Oracle is bound to the previous ABI, and so we had a ton of problems. We couldn't even get a database connection with strings without it. And so, like I said, entering with confidence, and then you learn something new. So, trick question. Anyone want to guess what the size difference is between the JSON and the XML? 50? Not quite. Close, but we had a 35% reduction just from moving from XML to JSON. And when you're talking 10,000 plus transactions a minute, that's a lot of network space and processing space that you got to pick up. The other thing we love about the JSON though, and just to be clear, this is a similar but totally fake transaction looking, although I'm sure the $9.95 would have been similar to if you paid for CppCon. We like the JSON for modern C++. This is the specific library we use because it's only C++11 is required. It's header only, which is, like I said in the beginning, something that we like. It's easy to read and use. The JSON is very portable. Not that XML isn't, but everybody's using JSON for everything now. The better type management is the thing that we really like. I can pass a number as a number. I don't have to add extra parameters in the XML to say, hey, this is a number. And so there's the URL for the library. If you download the code, we have a version of it that is then there, but by all means, go check out the most recent one. And in the point here, I say that they just recently put BSON in, which is the binary version of JSON. The other way we solved that problem was using base64, because EBCDIC, as well as some other things that we use like TLV, are binary, and we've had to pass messages over that are JSON but contain binary base data. So I'm going to get down to the code that we've made available. This is a very high-level overview. It's kind of an application and class layout. And the reason I say it that way, you'll notice the workhorse and MCP. These are the demo apps that I'll show. MCP, Master Control Program, of course. And the workhorse is representative of the base apps that we use for our other resource levels. We have applications that have to do encryption and decryption of card numbers, applications that are doing authorizations, calculating interchange rates and such like this. And again, our stuff is really modular. So we try to set these up to where we can have multiple running at the same time. If one goes down, we know it. If another app needs an application, it can find it as well. So our base application includes some of the resource files it needs for definition. We have a logger class in there, which it just generally was easier for us to include it for the demo. It's a class that works well for us. The configuration class is built off of the JSON. So when we make an app, we can get one developed pretty quickly. We give it a name, and it will by default automatically look for a JSON file with that name in the configuration directory and read the configuration in. The state support part is a define that you'll find in the makefile. And that's basically a switch. If you choose to add state support, that's kind of our resource level or our workhorse. And what that'll do is make it so that it will automatically try to connect to the opposite side, the master control, assuming you have the configuration, the JSON, and it'll give its update of its state support. We're only going to show two levels that we have in here, the resource level and the MCP. In production, we're using upwards of 5 levels. And the reason we do that is because certain applications are allowed to talk to others. There's separation for compliance and security and such. The app resource is shown in the middle because that's kind of the common file that allows both to know, hey, this is application of this type versus an application of another type. And that is the one spot that you kind of update for both types of applications that are common in the library. All right, so we'll get down to ZeroMQ uses what they call patterns, and I'm going to cover 3 of them because they're ones that we're using here. In the image here, I'm showing what would be the MCP. It makes use of an INPROC pattern, the pub side of the pub sub, and the dealer side of the dealer router. I have 2 workhorses here just shown as an example, but it's the same application in either case. So dealer router is a pretty much a one-to-one connection, but it's asynchronous. You'll also find the pattern of rep request, which is the synchronous version of this. We have it working dealer router this way because by putting the router on the workhorse side, we have other applications that are connecting to the workhorses can connect to each other. We use the MCP so that everybody knows who exists. And so that, if you end up looking at the patterns in the documentation, why we seem to have that one reversed. So the first part of the code we're going to look at here is ZMQ workhorse. So this part is in the workhorse side, of course, and this is the constructor. The things I want to point out is we have the JSON config that we're passing in, as well as the ZMQ context. If you haven't used ZMQ before, the one caveat you have is every application only has a single context. You can use multiple, I guess, but generally speaking in the documentation, you use one, all of your threads are built off of, or all of your sockets are built off of that. So we pass in our context, and then as you can see there, we have the socket with the context, and we're setting the type of that socket to ZMQ router. The string on line 16 where we have our connection, that's part of the connection class I was saying. And when you look at the JSON file, you'll literally see that it's just key value pairs. We build our connection string right out of the file. And then on 18, we literally bind right to that socket using TCP in this case. The logger, of course, is just set there so we can get some information out. And when I show the demo, you'll be able to see that. The flip side of this one is the dealer side. And so in the master control program, we have a basic class called Cortex. That line 175 where it's app identity ID equals JS, I'll get to that on the next slide. But in general here, we're using a shared lock. That st underscore mutex is a shared time mutex. We iterate over the apps that are currently in the map. And if it exists, then we drop down and we're able to create the socket. We connect to that specific application so that we can then send it a message. We use send action for a lot more than what the app shows. We actually send jobs between the different applications so that it knows what to do next. So for example, I mentioned we have a thing called interchange that we have to calculate. So when we're building a settlement file to go to Visa, we'll turn around and it'll ask our master control, hey, I need an RTI resource. It'll say, okay, go ahead and use this one that's available. It'll then connect directly to it and start issuing commands of, okay, give me the interchange rate for each one of these transactions. So it allows us to keep one main directory that keeps a track of all the resources, and then the other apps can connect between each other when they need those resources. And so that last, sorry, I popped by that. We moved to C++14 in order to use the shared time mutex because we were definitely having some contention problems as we bumped up the amount of connections that we had there. The other thing I'd say is if you read through some of the ZMQ literature, it will tell you that a mutex is an anti-pattern. And Kate Gregory once told me that working is a feature. And so for us, this is the way that we were able to get the app map to work well. We're still looking for a way to remove having to use a mutex, but we don't use the mutex on the sockets themselves. So back to the JSON, that last line that we had, that app identity, one thing that we really like about the header library that we have is you can write these to JSON and from JSON functions. And as long as it's within the scope and within the file and the object's default constructible, there's a few other caveats you can look at. It makes it that easy where in the last slide, you can turn around and take your JSON and just directly assign it to your object that you're going to use. So that was the dealer router. Next, we'll look at the pub sub. So state sub, this is part that we said there where it's inside the define. If you choose that you're going to define it to be a subscriber, it will use the state sub file in the workhorse. Again, we're passing in our config. That level there is the part where I was saying we have different levels, workhorse versus MCP. In this case, we also have others that you can put in there. Based upon the level, what it'll end up doing is setting up the socket to subscribe back to the primary server. So that's where we're taking our socket and set options with the ZMQ subscribe there on 23. Again, using the config that we get out of our JSON on 24, we build our connect string. It'll then drop into the while loop there and wait to receive messages from the master control of what the updated apps that are coming down are so that it knows what else is available for it to use. The flip side, back in the master control, we're looking at a piece from the Cortex here. It takes the app IDs that it's finding out of that app map, it gets the resource level, and then likewise, it'll go through, and if it finds anything of that level or below, it generates the message, turns around and has the publisher send it out. The ZMQ send more is basically an option that allows it to tell the app, hey, we're going to continue sending messages, and that's what that particular item is there. So the last one we got is the INPROC. The INPROC we found it to be great because it allows you to easily communicate between threads. And that's why you see it only in the MCP up top. And so once again, kind of looking at the Cortex part of the publisher, I want you to look at 83. This is where we're actually creating this INSOC, and you'll see it as ZMQ poll. And in hindsight, as I made these slides, I kind of found that the word publisher got used in the code a little bit in a lot of different places. So when you look at 85, where it's saying the INSOC bind, that INPROC part is important for ZMQ. The publisher part, that's the binding thing. We've also have a class that we use in-house that's for generating web connections. And we set that up with a ring buffer, and we actually generate the connection strings randomly and throw them into the ring buffer. So the word publisher in this case is, of course, just picked. In this case, that publisher is started in its own thread in the Cortex, which you'll be able to see. And so once it enters that while loop, it basically just sits there using the INSOC as a pull and just continually receives the messages coming in. Once it gets them, it ends up looking at the data and stuffing it back into the app list. On the flip side, also in the Cortex, because we want to be able to talk to everybody, we have a couple broadcast functions. This one is the broadcast all, but we also have a single broadcast. And here, again, we kind of have the INSOC set up, but this case it's set for a push. We're connecting to the same bind point. And likewise, we're using that shared time mutex on our app map so that we can iterate over the map, find any particular applications, and then push them over. That merge function that's there is another one you'll find inside of the app resource file that we have. And that just basically allows us to take two JSON messages, flatten them out, and put them together. So that covers pretty much all the patterns we had there. And so if everything goes right, we'll swap over here to terminal. Let me blow that up. All right, so on the bottom left corner, we have the MCP running. On the mid left there, I have a log system. You can see where we have Cortex and Heartbeat, master control setup, etc. So I currently have 3 workhorses running, and they are connected to the MCP. We'll take this first one, and I'm just going to cancel it out. Now, our timing setup is at about a minute. So in roughly 1 minute, we will end up seeing it disconnect. One of the things that we really like about ZMQ was the fact of it brought a lot of stability and things that we didn't have to worry about. Meaning, like, if you start a connection or stop a connection, ZMQ will either wait or try to reconnect automatically, depending upon the setup by default. That kind of had a bad point about it too. And I can show that in a minute here, but generally speaking, if you turn around and start up a bunch of client applications and they're waiting for the server to show up, it can actually generate a bunch of message requests. And so once your server comes up, it suddenly gets flooded with anywhere from 20 to 30 to 400 or many greater amount, depending on how the server is down, messages. And so we did find that you want to watch and use things like the sockets can have time set up like linger and such, and dead drop time so that you know if something connects or disconnects. In our case with the JSON configs that we have, I have it set for a 1 minute time. And so we can see workhorse there, which is that the port 951 just disconnected. Likewise, if I bring it back up, it reconnects quickly and it's logged there. The part where I was saying that you can actually kill off, so at this point I've killed off the master control, it's not running at all. And if I bring it back up, all the 3 apps that were just sitting there just automatically reconnected. None of the 3 apps noticed that it was gone, it didn't complain that it was gone, and the network stays relatively sane from the application's point of view. That was a lot nicer way for us to deal with massive connections of sockets without having to worry about it took care of a lot of the maintenance for us that the regular socket class that we had before wasn't doing. A couple of the things on the ZMQ, we did find that because the way ZMQ actually queues the messages, we get far more throughput, especially when we're sending a ton of messages than we did just plain sockets, because it will queue the messages and order them and send them all at once. That can be good and bad depending upon how it's set up. For us, we've found it as being a benefit. All right, so in the end, when you learn not to enter a water hole on a big heavy bike as fast as you can, you don't plow so much water over you and you don't fall down. That's the end of the picture learning. We have applications that we use called like DB Cache that originally would take upwards of 90 minutes to refresh. Now, if you can imagine, just as an example, if you look at your credit card, you have that first 4 digits, and there's so many credit cards with that digit, we actually have to keep these kind of things in a memory table in order to quickly index and be able to get these authorizations back. And there were points in time where the legacy apps would literally take so long to update that by the time they updated, they were starting to refresh again. With ZMQ, the way we were able to change out multiple parts of our app, we were able to stream that data back far faster to the point where we got our updates down from 90 minutes to 10 minutes. That in turn allowed us to speed up our authorizations because it can now look up much quicker using the database tables. In memory, we got a 5 times speed up on our transfers for authorization transfers. And of course, being in credit cards, we use some interesting devices called HSMs. When you look at the checkout code that we have on GitHub, I linked to one of the companies that provides these devices. They manage all your cryptography keys and just really interesting. We were able to also thread and get the communication with ZMQ to these HSMs going much faster, which got us also a 3 times speed up. But generally overall for us, using these 2 technologies between ZMQ and JSON, aside from moving to Linux and C++ from Power Builder, we've started to get a much more redundant and capable platform that we're looking and can be able to scale out. Where we used to only have an A/B setup with a couple daemons, we're now able to have 5 of our interchange apps all register at once with the automation. If one drops or becomes unavailable, the apps already know because of the way we're passing down the pub sub. These are the other ones you can rotate to. And we've also started now getting to the point where we're taking our master control and it's fault tolerant to where they too are running in parallel. We'll keep 3 or 4 of them up. If one drops, the next one is automatically in scale and starts running as well. And so code and slides and all of that are already up and available on this link. And I'll make sure that the link is up on the speaker page. And the other people down there, of course, are the people that I didn't write it all myself. So that's the rest of the team. And that's my talk. Thank you. So there are a couple minutes, but otherwise for questions, otherwise you can hit me up at all. I love transactions. This stuff's fun. No? All right. Oh, yeah.
So in distributed messaging, do you guys have to deal with 0MQ in sense of duplicate messages or messages coming out of order, or it's more like networking communication and everything had been dealt for you?
So no, the message out of order is something that we do have to deal with. We actually have had to make sure, so literally if we're pulling down 10,000 transactions at a time to be able to process them, as we've been moving them across, the ordering stays consistent when we pass through ZMQ, but we do sometimes have to work with the ordering as we move them between the apps. So for example, I may pass that 10,000 over to the RTIs or the interchange apps, but then they get split up between 2 apps. And so now I need to make sure that the ordering comes back in the same way so that we get the same kind of inserts back into the database. So it is something we've had to watch for. We've just had to program for it.
Mm-hmm. I also wanted to ask in the beginning, so the original code had a lot of C++ already, or C?
No. So our original code was primarily built in Power Builder. I would say we have about a 70-30 split. 30% of it was written in C++ Builder, which was Borland's original product from, I want to say, the late 90s, early 2000.
So I'm wondering, what was the decision logic behind, oh, okay, we're going to go to C++, one of the world's most complicated languages, rather than, I don't know, .NET, for example?
Well, I'd say I go from this point, there's 2.5 million C++ programmers around. We have the bulk of them here, and it's fast. When we turn around and look at Linux and GCC and all the open source items that are available, it's the best way to get the fastest response possible. I will say it's been interesting because we do a lot of what is basically text and data processing using C++. But who wouldn't want to write in C++ and Linux versus Windows and Power Builder? Not that I dislike Windows.
And one thing I wanted to mention, it looked like your mutex usage could be like a little bit optimized. Actually, here in CppCon, we were reminded that you really want to hold the mutex for as little as you really need.
Yep.
In your first example, it looked like once you got the like application ID or something, you actually could have released the mutex and do whatever you need with the. I think you were logging it.
And actually, I will say that you're absolutely right. I'm sure there's other areas we can optimize the mutexes, and I enjoyed Rainier's pre-conference class where I learned a lot more about mutexes. So that'll be happening when we get back to the office next week.
Cool.
Thank you.
So is there any reason why you preferred JSON over something like protobufs?
Size.
Size.
So we looked at protobufs, we looked at some of the other larger scale, and when I say larger scale, in-memory databases and such, but the company in the past, I say they're very adamant about making sure it's stuff that we can use that's small, that's easy to learn. ZMQ and protobuf were kind of put side by side, and the decision was a little bit before I got there, but ZMQ was the one that they went with, and at least from the CPP ZMQ, that was an easy library for us to use.
You can exchange messages that you serialize using protobufs over ZMQ, so you compare those two together. It's more, protobuf would be the replacement for the JSON piece rather than the ZMQ piece.
Right, and at the same time, we also use JSON though in other applications that we have, and so for us, it was more of a common platform that we could use everywhere. It allows us, so like I said, we actually have a web connection piece that we've added so that we can turn around and build REST APIs. We have a lot of web APIs where, as I stated, we have like gym groups that are connecting to us, and you know that over secured connection with the technology that's already out there, JSON was more apt and more usable than switching to protobufs.
Cool, thank you.
So I was going to literally ask his question, but I have one other question. Why did you choose that specific JSON library? I've looked at it and I've looked at some others, and I believe the nlohmann repository actually claims not to be the fastest, and so they hang their hat on easier to use. So I was wondering.
You're right, it isn't the fastest, and I saw that as well, but from an implementation point of view, that's where we really like the small header files. The ZMQ is literally the largest library that we implement and use because we like those small header files. If you download the code, you'll also see we use like args.hxx because for being able to pass arguments in from the command line, it too was a single header file. Not that it is the best, but it is the best for our company at this point.
Okay. Sounds good.
Thank you. Anything else? So the applications and their flow, when we have them set up, is based upon the particular processes that we're using. So the code that you guys can download, we literally took some of our applications and I was given the ability to strip out everything possible, which meant stripping out a lot. The master control that I show here, we actually have complete job control in. The make file has the ABI in there because we connect to an Oracle database. Our Oracle database helps keep job ordering for us. So for example, I said we do batches when you look at credit cards. So for example, we can turn around and say, well, for this particular cycle, you're going to end up doing the visa. Here are the 5 different jobs that have to happen in process. And so the master control will then trigger off and say, hey, you go over to this one and start this job. Once that job's completed, it'll be passed on to the next particular application, and the applications can then communicate between themselves, just getting updates of which job to run next from the database.
Do you consider to use event-stream processors like Storm or Apache?
No. Again, the company likes the scalability is important, but they want to be able to work with more things in-house. These were the technologies they kind of went with from that part of easy and manageable for a small team to pick up and work with. At $50 billion a year, we are a large processor, but in the scale of things, I think last year we were listed as like the 10th largest. So we're growing that way. But I'll definitely look at that as a technology. I mean, that is the point. We are definitely looking at where we can grow different items. When it comes to things that are in production and you're working with a group of what people want to implement or what they can implement, it's like we're still running on CentOS 6. I would look forward to moving to CentOS 7. And sometimes when you're running on an enterprise thing, the company wants to stay with what they know too, because that's what they experience and are stable with.
How do you, you mentioned that formats from companies are different, like some AppDic that nobody really remembers and whatever. Do you have to maintain multi-protocol formats, like multiple formats of their data? Oh,
absolutely. Visa, MasterCard, and American Express can't agree on anything from my perspective, as this is being recorded, from my perception. I mean, there are many things like we all handle transactions. The example I gave of a transaction where I was comparing the JSON to XML, that was about the size of, say, an American Express transaction or a Discover transaction. I will say a MasterCard transaction is probably 15 times that size in the amount of data fields that it holds. And then on top of that, you know, EBCDEC, there's a lot of data fields that are actually binary. And so you're literally pulling apart a binary field where you're saying, well, this third character is this field, this 10th character and 11th and 12th character is another field. And then that is sometimes different between the different vendors. Absolutely.
Do you end up normalizing all to one universal representation inside?
In some cases where you can, but then at the same time, you know, like I'm saying, if we have one credit card like American Express or Discover that only has a minimal amount of data fields, in my experience, one of the projects I work on is a lot of the interchange calculations that happen. The difference, the commonalities between the cards is probably 15% comparative to the amount of differences between the cards when it comes to data fields that are being passed back and forth. And it's interesting to find the amount of data that is actually attached to a particular transaction. So for example, when you rent a car, there are, you know, an extra 15 fields, if you will, that get passed in that aren't there when you just go to the grocery store and buy groceries.
So, sorry, I keep following on this subject. Do you end up applying some sort of polymorphism to deal with differences?
In the places where we have been able to, as we started to write, so that's one of the things in the C++ where we can, yeah. I have some common classes, for example, that we use for interchange, and then we build off of them. But in some cases, the data is just different. And in one of the talks that we saw, you know, at the OOP is Dead, which I thought was a great title, but, you know, it wasn't necessarily where he was going for, that idea that polymorphism can be great, but then sometimes if you get your classes too deep, you know, sometimes it's better to make the data be able to pass through a particular class, which I kind of relate more to being more like a channel, whether that's the terminology everybody uses, but taking a data structure and just letting the classes work on that individually and pass it along. Yeah. Cool.
Thank you.
Thank you.